Subsets. Given an integer array nums of unique elements, return all possible subset. The solution set must not contain duplicate sets. Return the solution in any order. So basically, they have given the subset that is 1, 2, 3. And for example, if this is the set which is given, if this is an nums array which is given, then the subset of this is one is empty array, then one is 1 itself, 2 itself, 3 itself, then next comes 1 comma 2, then next comes 2 comma 3, then next comes 1 comma 3. Okay, these are the subsets which are happening of these particular numbers. So if you see, these are all unique subsets. You cannot have a subset like this is 1 comma 3, right? You cannot have something like 3 comma 1. This is not possible. We don't have to give this fashion. And if you see, the way we are making is using the 1 over here, we are using 2 over here, and we are using 3 over here, right? So one by one we are iterating the nums array and removing the first character, first integer, and taking the next integer. Let's see how to do it. So in short, we are I'll tell you which algorithm we are going to use it, but to get an idea of how to create these subsets. So these are the subsets, right? So basic idea is we have to have an empty set, that is must. That means we are using one, we are not using one. We are going to pick one, we are not going to pick one. We are going to pick two, we are not going to pick two. So it's like one, we are not going to pick one. We are going to pick two, we are not going to pick two. We are going to pick three, and we are not going to pick three. So this is the way we have to make subsets and come to a conclusion. So basically what we are doing, when we are using the one, we are going back and not picking it. When we are using two, we are going back and not picking two. We are going back again using three and not picking. So always we have to go back, right? That's called as a backtracking algorithm. So over here, if you see, it is every n has every n has 2 raised to n subsets which we are forming. For every n means these are the number of elements in the nums array. For every n, we have 2 to the power of 2 to the power of n subsets we are forming. That's the reason the time complexity wise it is O of n raised to 2 to the power of n. This is the time complexity for this particular approach of backtracking, because there is no other method where we can form the subset with different combinations, but only backtracking can help us, and that is also called as a recursion. Let's see how we are going to do it. So we have the number 1, 2, 3. This is our number, right? So we are going to take an empty set first, okay? And now we will start our backtracking. We'll take one, will not take one, so this becomes empty. Now again, we'll take two, not take two, so here only one is pending. So I'm not writing the curly braces. Let me just, okay, let's do this again. So this is an empty set. Okay, empty set. I'm creating a box because I'm unable to do it on this board. We are taking one. We are not taking one. We are taking two. We are not taking two, right? Then we are taking two. We are not taking two, right? Next, we are going to take three. We are not going to take 3, so becomes 1, 2. We are, what's this? We are going to take 3, so it becomes 1, 3. We are not going to take 3. We are going to take 3. We are not going to take 3. We are going to take 3, and we are not going to take 3. So if you see, These are the combinations, these are the subsets which we have to return them as an answer. These are the subset which we have to return them as an answer. So if you see what exactly we are doing, we are taking one, we are going back. Okay, we are going back and then using the empty set and then iterating the next nums array. So when we are using empty set, when we are saying it is empty, that means we are removing that element. So we are taking one, this is 1 2 3 over here, right? This is the number which we have it. I mean, this is the number which we have to do the subset all about. So these are all numbers. I have not added comma, but I hope you guys understand that. So in this nums array, when I'm saying I'm taking one and then I'm going back and removing one. Again here, I'm iterating the nums array. I'm taking the next element, that is 2. I'm taking the next element 2. Again, I'm going back. I'm removing the 2. Next, here also I'm taking the element 2, I'm going back and removing the element 2. Then I iterate the nums array again and then take the last number, that is 3. I'm taking 3, I'm removing 3, going back and remove 3. Taking 3, going back, remove 3. Taking 3, going back, remove 3. This is something called as backtracking because we are going back and then again removing it from them. So this process of repeating this process is called recursion, and going back and removing it and taking another one, that is called as a backtracking process. And time complexity wise, it is O of n, O, big O of n, because n are the elements which we have to iterate it, 2 to the power of n, because we saw every number has two possibilities. Every number has two possibilities, and that's the reason it is 2 to the power of n time complexity. In space wise, it is O of n, because in the space complexity we are using a list of integers. So that's the reason it is going to take a space O of n space complexity. Complex static of integer subsets in nums of integer. Let's call this a result list where we are going to add our result new array list. Let's have a backtracking method where we are passing result list, nums array. Then we are also passing the empty list, if you remember. That's the reason I'm creating this new array list. And 0. 0 is nothing but I want to have an integer from where I'm going to start my algorithm. And for return, I'm going to return result list. Now let's define what is backtracking over here. Of list of integer, that is result list, then new array list, set, then we have nums also, int of nums, then we have a start, int of start. And this we are defining the backtracking method. This is only the things which I have written, that is result list, the nums array, the temp set is basically an empty set which we needed to add our numbers, and 0 is our start. So first thing we are going to and we are going to add our empty set, right? And then we are going to start our loop. Int of I equal to start, I less than nums dot length, I plus plus. So first thing what we are going to do is, in the temp set we are going to add nums of I. That's the first element which I added. Then I go back. That's the backtracking that I'll explain you. This is the we are going back, and then we are removing the number, right? We are removing the number. Temp set dot remove, temp set dot size -1. We're just removing that number. And when we are doing the backtracking, we are going back, right? And then we are also taking the next element which is available. So for that, I'll just mention here, this is a temp set. And so we are taking next element, that is start plus 1. The next element, when we are iterating, that will be taken after removing this after removing one element from the temp set. We are taking the next element. Basically we are doing this while iterating that particular array. So first we are adding one, going back, removing that one, and at the same time we are also iterating and increasing our number of elements. We are taking two. First we took one, then remove the one, then we took two, then remove the two. That is what these steps are mentioning. And time complexity wise, O of n, 2 to the power of n. And space is O of n because we are using this result list. Thank you for watching.